All right, so this lesson is on what we call completing the square. And it's something that you were exposed to back in Algebra 1. Everybody remember completing the square? Yes, no, not so much? Okay. And we're going to work with something called algebra tiles today. Has anybody used algebra tiles before? No? Okay. I think it makes it visual. I think it makes it make sense. All right, so the first thing we want to do is we want to review some of these methods that we've done thus far. So when we are solving a quadratic equation and we notice that there are no plain old x's, we only have x squareds, what's the first thing that you're going to do to solve something like this? Subtract 14. So when we take away 14 from both sides, we'll get 2x squared equals, and what's 70 minus 14? Okay. So our first steps are to isolate the x squared. We're trying to get that all by itself. So we have 2 times x squared equals 56 right now. What's the next step going to be? Divide by 2. And when we do that, x squared will be equal to what? 28. Okay. So we've got our x squared all by itself now. We've isolated it. What's our next step going to be? Take the square root. So the square root of both sides. And we'll get x equals 28 is 4 times 7, right? So what comes out? 2 square roots of 7. But our third step is to don't forget the negative value. So we want to make sure we put that plus or minus out in front. So we use the square root method when there is no x. There's no bx in here. We had a 2x squared, we had 2 constants, but no bx. Okay? Factoring method. If we're going to factor x squared plus 2x equals 48, what's the very first step of that one? Bring 48 to the other side. So the very first step is always to get it in ax squared plus bx plus c form, which is standard form. So x squared plus 2x, it was positive 48 on the right, it will be a negative 48 on the left, and we set it equal to 0. Okay. Then what do we do? Factors of 48 that do what? That add or subtract to get the 2. So we want factors of c that add or subtract to get b. Or you can make your t-chart. Okay, if that works for you, make your chart. that's your preferred method, put that in instead. So factors of 48 that can subtract to get to 8 and 6. So you write your 8 and 6 in there. Good. We want the bigger one to be positive and the smaller one to be negative, so we get a positive 2 in the middle. And then what's the last step when we're solving this? Set them both equal to 0. Okay, so if x plus 8 equals 0, then x is going to be negative 8 when I bring it to the other side. And if x minus 6 equals 0, then x will be 6. Okay? You bet. Once you have done enough of those and you know it's going to be the opposite, there's no reason to have to write these extra 2 steps. You can just write the answers down. You bet. The only time I would caution against that is when it has a leading coefficient in front, and then you have to actually work it out. Okay? You bet. All right, everybody good with those two? Review of some of the things we've been talking about. Today we're going to talk about the completing the square method. Okay? So I have a worksheet for you. A worksheet / exploration / assignment. It's coming your way. And we get to play with toys today. Yes, sir. You bet. Those are exact. It'll be a positive 8 and a negative 6. Because if we want the x to be by itself, we have to add 8 to both sides. So it'll be just the opposite of what was in the... Actually, you were right. Put plus 8 here. We just drop this down. There you go. Minus 6. And then when you bring them to the other side, they'll be the opposite of whatever was in the parentheses. Just like our h when we do our vertex of our parabola. Okay, so you get to play with algebra toys today. They are bags of tiles. One more for you. Hopefully the bags are somewhat closed at the moment. Go. Yes. Yep, they're coming. There you go. Oh. So. Everybody get a set of tiles and a sheet? All right. So our goals today are to arrange the tiles to form perfect squares. What do we mean by a square? What's a perfect square? Yeah, both sides have the same measurements, right? So if one is 6 across, the other would be 6 up. Okay, so we want perfect squares, not rectangles. And then we want to come up with a rule for making perfect squares. Okay, just let me open my file here. All right, so our goal is to arrange the tiles in the shape of a square and figure out what tiles have to be added to make a perfect square out of x squared plus 4x. So notice that you have blue tiles and you have red tiles and you have green tiles, right? Your blue tile is x by x. That's a positive x squared, the big blue one. Okay? When you flip it over, it becomes red. That would be a negative x squared. Okay? Then you have some green ones that are positive x. When you flip those bars over, they become negative x. So they're just a 1 on one side by some x value up and down. Whereas the x squared is that same x value sideways and x up and down. And then we have some little ones. They're red on one side and kind of a beige color on the other side. Those are our positive and our negative 1. Beige is positive and red is always going to be negative for us. Okay? So we're really only going to need one of those x squared tiles each time. So if you want to organize your stuff and not worry about losing it or whatever, put the rest of them back in the bag. That's okay. But how are we going to arrange this so we can make a perfect square out of x squared and 4 of these green ones? So I'll let you try. See if you can figure it out. I just want an x squared and 4 green x's, 1 blue x squared, 4 green x's, and you may have to add some beige ones to it. Kayla's got the right idea. Brenda's got the right idea. Good job. Very good. This is what I'm seeing Brenna and Laurel doing. And I love what they're doing with this. Move this down a little bit. Everybody agree that Brenna and Laurel have a perfect square? Does that look like a perfect square? Okay, but it's kind of hard to tell the dimensions of that square, isn't it? Okay, if I wanted to know how wide it was or how tall it was. Okay, so let's use this x squared as our corner piece, and can we arrange those same tiles in some way to the side and below in order to get a perfect square. Okay? What I need you to do is to have something like a bounding box here, because we want to be able to find the dimensions of this. So we want something like a line here and a line here. That's going to help us get our dimensions when it's all said and done. So how can we arrange them now, keeping that one top and side as it is, to get a perfect square? Joseph's got it. That's good. Kaylin's got it. Good job, good job. Hey, Kobian's got it. All right, this is what I'm seeing now. They're pulling, oops. They're pulling this guy over here and this guy over here, and then placing these four here. Do we have a perfect square? Because that's what we need to complete it. So let's talk about those dimensions. Very, very good. So we had to add these guys, right? Otherwise, we couldn't have a perfect square. We were lacking something. So we started with our x squared. We had a total of four of those x's. And this is what was necessary to complete that square. Is everybody cool with that? Okay. What is the dimension of this square now then? How long is this side right here? It's an x squared, so this is x and this is x. X by x gets me x squared. Everybody agree with that? Okay. How long is this? We have two of these x's. This part is 2. This dimension's already x, but this side is 2. And this side is 2. This distance here is only 1 in length, 1 by 1, and this distance is only 1 in length. This part is the x, this is your x side, and this is a 1 by x. Okay? Everybody okay with that? The whole thing has x for its area, but it is 1 this way and x this way. That's how we get 1x for its whole dimension, for its whole area. So this is x plus 2 by x plus 2. That's the area of this figure. And when we work it out, we get an x squared plus 4 of these x tiles plus 4 of these small tiles, 4 of the ones. So we had to add 4 to make it a perfect square. Everybody good with that? Okay. If it helps you to remember it, you can sketch the boxes in your on your little paper. And we're going to look at the next one. Now we've got x squared minus 6x. So we're looking for, oops, I'm sorry. Did I do the wrong one? That was mine. Okay, so now you're doing the next one. X squared minus 2x plus c. What c are we going to need to add to make that a perfect square? So start out with your x squared box again. And this time, instead of 4 of the green tiles, what do we need in order to have negative 2x? 2 of the little red x tiles. So we're looking at these guys. And those are the only ones that we're concerned with at the moment. And again, we want our kind of our bounding box so we can figure out what the dimensions of this guy is when we're all said and done. So we want to line up our x squared in the corner. And we're going to make a perfect square. And Sarah's already an expert. She's got it. Good. Tyler's got it. Veronica's got it. These are quick studies. Okay? So I'm seeing this. So what's missing from our square to make it a perfect square? Just a single one tile, right? Now, should it be beige or should it be red? Beige. Why is it beige? You're right. Good, because a negative 1, negative x times a negative 1 times a negative 1 is going to get me a positive. So very good. It's going to be a beige tile. Okay. What are the dimensions? Positive or negative 1? Negative 1. And when we multiply x minus 1 times x minus 1, or x minus 1 quantity squared, our perfect square, that's what we're trying to get to, we get an x squared minus 2 of these x's plus a 1. Pretty good with that? If you want to sketch it out, here's a chance to sketch it out on your sheet. If you don't want to, that's okay. If it helps you remember, visual learners tend to do well with this kind of stuff. If you're visual, you'll want to sketch it. Okay? Next one. X squared minus 6x plus c. We have to figure out what our c is to make that a perfect square. In order to find it on one side, we want our x squared to be on one corner and everything building off to the right or below. I think Cobian was the first one done. Tyler's close second. Veronica's got it. Sydney's got it. Macy's got it. Good. Joseph's got it. So how many do we have to add? Very good. X squared plus 6x plus what makes a perfect square? Nine. Good. Okay. So x squared plus 6x plus 9. Everybody get it? Nobody needs to see it up here? Okay. So we're getting faster. I don't know if you have enough tiles here to do this one. But x squared plus 8x plus c to make that a perfect square. Can anyone make a prediction of how many little beige colored tiles we'll need? There are a couple people with the right answer. Let you think a little bit. How many are we going to have to add? Heard another whisper of it. To make it a perfect square. Those are quick studies. Well, when we make our box, there's our x squared box. I should have done it in blue. Apologies. You're noticing a pattern, aren't you? We're dealing with 8 x's now. So how do we have to split those in order to make this perfect square? Yeah, 4 here and 4 here. So we're splitting it. We're taking half of that 8, aren't we? And then what do we do to it in order to get all the right boxes down here? Yeah, we square it. So 1/2 of 8 squared will be what our c is. Okay? Half of 8 squared gives us our c. What's going to happen with this guy? Good. We've got somebody already predicting. Now we've got a problem, don't we? Yeah. So we only have 5 tiles. Not going to work with tiles, is it? Not unless you have a pretty heavy-duty scissors. These are pretty strong tiles, right? Because what do we have to do? We've got to split those 5 tiles evenly, right? So how many would be along this one edge? Half of 5 is 2.5, and the other way, 2.5. So there's my 2.5 and 2.5, and look at my messy little itty-bitties down there. I'd have to cut those up as well. So what is half of 5? You said that's 2.5, or 5 halves, right? If I square that, 5 squared, 2 squared. So all of these little tiles down here would be a total of 25/4 if I broke them up into 4s. 4, 8, 12, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we'd have to have smaller tiles. Okay? So gather your tiles up. We'll put those back in the bag. And you found the pattern. So this should make sense. Pass your bags to the front, and we'll finish going over this. Don't lose your worksheet. We'll finish this tomorrow.